I'll probably even talk louder than this because I get so excited when I talk.
All right.
Is that good?
Yep.
Great. We can start whenever, actually. Should we just get going? Yes. Great. All right, welcome, everyone. We're even going to start 1 minute early. Oh, no, 9 seconds early. So welcome to the last day of Build. I'm very excited to talk to you all today about some of your compute options in the cloud. So we're going to talk about your options between Kubernetes, containers, and serverless. This is a very short session. It's only 20 minutes, so I'm just going to do a quick look at all of these different options and hopefully equip you with the knowledge that you need to help make good decisions in writing and building cloud applications. We've got some cool demos. This should be a lot of fun. So one concept that I do want to start with when we talk about our compute options in the cloud is this idea of cloud native. And cloud native is the thinking that when you're building and writing applications for the cloud, rather than just building them the same way that you would have built them in the past, running on premises, how can I actually use the strengths of the cloud, take advantage of the unique capabilities that the cloud offers, and intertwine that in with my application? Make it so that my application is taking advantage of the strengths that the cloud provides so that I'm not just writing it the same way I always have. Maybe I'm writing it a little bit different, but because of it, now it's highly available. It's available in multiple regions. We can tear it up and tear it down in a moment's notice. So kind of the goal for all of this as you think about your compute options is, how do I make my application so that I'm taking full advantage of the cloud? Now, that's my definition of cloud native. There's a few other ones. Maybe for the topic of this conversation, the best definition might actually be in cloud native in 2019. It actually doesn't matter. Whatever tool you choose, whatever platform you choose, somebody on Twitter that you've never met is going to tell you that it was the wrong choice. And why would anybody ever write applications this way? Only Kubernetes, only serverless, whatever else. So don't worry. Whatever you choose, you're going to be wrong to somebody. That's all right. Do the best you can with the knowledge you have. So to start with, the first one in this is containers. And I just want to spend a little bit of time here kind of talking about what containers are, mostly because I often hear them being used a bit more liberally than I think what containers actually are for at their core. So at their core, to me, containers is a tool that allows you to package your app along with its dependencies so that it can then be run in a portable and reliable way. So containers, in my mind, is like a super amped up and very cool zip file. Like right now, I'm presenting my deck in a PowerPoint presentation. If some of you want a copy of that deck, I could take this deck, I could stick it in a zip file, and I could email it to you. By sticking it in a zip file, I'm not changing anything about the PowerPoint. I'm just choosing it to package it that way. Now, containers do much more than a zip file. It actually packages up the entire environment, the OS, the dependencies along with your app. But it's really just a way to package up your app in a nice, convenient way. Now, when you're working with applications in containers, you've got, maybe your logical application. You might have each one of these little dots represents maybe a single Docker container. Like maybe one of these dots is an API, another dot, maybe that's a front end, maybe another dot is even a database. And you can containerize those. And the benefit of containers is now wherever it runs, however it runs, I can spin it up quickly and have it run consistently. So just a very quick demo here in terms of containers. So I'm over here now in Visual Studio 2019, and I have an ASP.NET application. It's a really simple one. In fact, all the demos I'm doing today are going to have to do with news. So this has a little news theme to it. So I've now written my application here using ASP.NET Core. I'm going to go ahead and click the Run button in my Visual Studio experience. And it's now spinning this up so that in my browser now, inside of Edge, in this Windows 10 machine, I now have my application running. And I can give this an RSS feed, like the Azure blog news feed. And my app works. It lists me the latest blogs that were posted in the last 24 hours. So this is good. I have my application here. But right now, it's just running locally on my local IIS server, on my Windows 10 machine. What if when I actually want to run this, it might be running on a Linux machine that I don't have control over? It might even be running on a machine that doesn't even have .NET installed. So how do I make sure that this can still run in a consistent way? And that's where containers come in. So using containers is actually super easy. I can right-click a project in Visual Studio, and I can come in here and say Add, and I'll zoom in a little bit so you can see. And in Visual Studio, there's actually a button to add Docker support right there. So when I click that little button, which I will in a second, it's going to look at my project. It's going to say, OK, I see this is .NET Core, so do you want Linux or Windows? I'm going to say I want a container that can run on Linux. And now it's given to me what's called a Docker file. This is kind of the recipe, the cookbook, the instructions that will help build my environment, my version of .NET 2.1 in this case, the OS I want to use, and all the files that I need. So I can now take this Docker file, and I can actually build it using Docker. So I'm going to say, hey, go follow all those instructions, build a container. And now I'm on my Mac. Okay, so this is a Mac now that's running this, and I can now run that application. I'm going to expose a port. I'm exposing port 8080, and I'm mapping it to a port on the container. And I'm just pointing it to the container I wrote. And so now when I run this container on my Mac, I'm getting the exact same runtime environment, all of my dependencies packaged together, and now exposed for me here. If I actually come over here to a web browser, I should be able to go to localhost 8080, and we will see here's our site that we built, running in a container on my Mac. I could go put this on Linux. I could go run this on a Raspberry Pi. It doesn't really matter. Docker's going to make it so it all works. Okay? So that's what containers are and why they're useful. Oh, actually, before I go into Kubernetes. So let's talk about some of the challenges of containers. So imagine now where you see this Docker container running. Instead of just being my laptop, imagine this is now a production laptop. Okay? I've now promoted this to production. Let's say I even expose port 8080 on my laptop so anybody in the internet can now go to that Simple News Reader site. Okay, so if you go to simplenewsreader.com, it's going to hit this container running on my laptop. And there's a few problems with that. The first, what happens when my laptop runs out of batteries? I'm not plugged into any power right now. What if it crashes? What if it has to update? And if that happens, my single container here, which is super nice and portable, isn't available anymore. So anyone going to that website, they're going to hit an exception. And the other issue here is, let's say that it goes viral. Let's say everybody loves this really simple RSS reader, and thousands of people go to this container. My CPU is going to start spinning. It's going to start complaining. It's going to slow down and maybe crash. It's not going to scale very well. So that's actually where I want to segue into the next aspect, which is Kubernetes. And what Kubernetes is aiming to do is provide a platform that lets you manage, scale, and maintain your app in a reliable way. So it takes your containers and it's going to map them across a bunch of infrastructure in a very reliable way. Okay, so Kubernetes works with containers to make them more reliable and highly available. It is a tool for operators. So you can almost think of it, imagine instead of me just having one laptop here, what if this whole stage was filled up with servers? I had like 20 machines here. And now I want to run my simple news feeder across all 20 machines. Well, it would be a pain in the butt to have to SSH or remote desktop into every single one of those 20 machines, say Docker run. If one of those machines crashed, I have to plug in a new one, remote into it, and run that container. So that's all Kubernetes is doing. It's just doing that process of taking a group of servers and meshing them together so that I really just work with a single API surface. And I say, here is my application. Maybe it's made up of a few containers. And then Kubernetes is going to go and spread that workload across your entire cluster. So in this case, if you have one container that needs a lot of resources, it's going to automatically run that on multiple servers for you. If you have another container that's not being used at all, maybe it's not running anywhere. Okay, so Kubernetes just makes this very easy for you. It's about orchestrating your containers, making them more available. All right. So we have a simple demo here. Let's take this same app that I started with, and there's actually another cool button in Visual Studio where I can say add container orchestrator support, which means give me the files that I need to now deploy this to something like Kubernetes. So I'll go ahead and say OK here. It's going to generate for me, in this case, a Helm chart, which is a way to deploy containers to Kubernetes. And here I have, let's close this Docker session. I'll zoom in a little bit. I have an Azure Kubernetes cluster that I've deployed to Azure that I can interact here through the command line using this this tool called kubectl, or kubectl if you really want to. And if I come in here right now, I'm going to say get my pods or kind of like get my containers, and I don't have any right now. I've not deployed anything. So let's go ahead now and deploy my simple feeder, my newsreader app to Kubernetes. So I've now deployed this to Kubernetes. I said, here's the container I want you to run. In this case, I actually told it, I always want 3 of these containers running at all times. So if I actually come in here now, and I say get pods, you'll see that Kubernetes has now run 1, 2, 3 copies of my simple feeder app. So now as people come to my website, Kubernetes is going to route them between these three, load balance it for me. The other nice thing that Kubernetes does is if we actually just go ahead and add a window here at the bottom, I'm going to watch this. So you'll see I have 3 pods running right now. In this bottom window here, I'm going to delete one of them. And you can imagine, rather than me manually doing the delete, I'm actually, like, imagine that one of these servers behind the scenes disappeared into a black hole in the middle of nowhere, okay? So here, oh, it doesn't look like my copy-paste worked well, so let me make sure I have this. This one here, I want to delete one of these pods. We'll just grab the one, 26DZW, okay? So I'm going to delete this pod, and I want you to watch what happens as soon as it deletes, what Kubernetes is going to do. So if one of these crashes, if one of these gets deleted, like I'm telling it to, it's terminating right now, but as soon as it terminated, you'll notice that 26DZW is gone. Kubernetes instantly realized, oh, shoot, one of my containers crashed, and it instantly grabbed one of my other machines. It spun up the container on another machine, so I always have 3 that are available. And in the same way, if I sent a load test at this, it might add 4 or 5 or 6 replicas of this container automatically for me. So Kubernetes is this nice orchestrator that's making it so that I can coordinate my containers across multiple machines in a very easy way. All right? So that takes us to kind of the final pivot here for the last few minutes, which is serverless. So where does serverless come into play here? Now, serverless is also running apps that you can almost think of like containers. But in this case, serverless is all about making it so that you manage less, right? In the previous demos, I was building Docker files. I was using the Kubernetes control and the Kubernetes API. With serverless, you don't manage any of that. You simply give your application code. You give it to Azure. We have a fully managed cluster. We have a way to keep services highly available. We look at your code, and we just run it all for you. You manage none of that. You don't have to worry about scale. You don't have to worry about availability. You just give us the code, and we will run it for you. It's optimized on developers, allowing them to focus on their code and not have to worry about focusing on how to keep everything up and running. So kind of the hero service of serverless is Azure Functions in Azure. And there's a few nice things about it. There's a bunch of languages you can write these functions in. But one thing I want to call out quickly is that Azure Functions are event-driven, meaning if I go into my Kubernetes example here, and we still see these pods, these containers are running 24/7. They're always listening for somebody to go to this website. They're just running constantly. I'm paying for some compute to run these things. Well, with Azure Functions, rather than doing it that way, I actually map my code to some event. Maybe that event is, hey, I dropped a picture in a storage account, or there's a message that fell in a queue, or somebody hit this HTTP endpoint. When that event happens, the cloud will take your code and execute it for you, and when it's done, it will get rid of it. So all you have to write is the little bit of code that you want to happen on an event, and everything else is managed for you. It's completely event-driven, and you only pay when your code is actually running. So there's a bunch of different event sources here, HTTP queues, event hubs, IoT devices. Here, this is an example of an image that's coming in. We're resizing it and running it through machine learning. All I have to write are these little bit of code that I want to be event-driven. I publish it. I'm not dealing with managing availability. I don't have to look at any of these, hey, is this up and running? Do I have enough capacity? I just give my code and everything else is taken care of for me. So Azure Functions is a little bit more like this in our example. You get your app, you assign it to an event, and then you just publish it to the cloud, and we will just spin up and spin down and run these things as you need. You're not managing any nodes. You're not managing any infrastructure. It's event-driven, serverlessly scaled, scales very rapidly. It's a great option here for your compute. So before we do kind of one final demo, this is a little bit of a recap. Like where should you think about hosting your code? And there's actually a spectrum that we often talk about in the world of compute, which is on one side you have highly productive services. These are services where you don't have to do a whole lot to manage or maintain them. You see Azure Functions is on the far right of this. I really just write my code, I push it, it takes me 5 or 10 minutes, and I have something up in the cloud running at massive scale, highly available. And on the far left-hand side, you have more control and more management, meaning you have to manage more things, but you're giving up a bit of that productivity. Hey, I can't just take this image resizing app, get it in a VM in a highly available, highly scalable way. I have to spend now a bunch of work getting that ready to go. So we kind of have this spectrum here where you've got like just straight up VMs on the far left. Then you move to Kubernetes. We have things like app services, which is like specialized for websites, whether it's a container or not. and then you have Azure Functions here. The general guidance that I always give people is when you have a new problem or you want to refactor an old problem, start on the far right of the spectrum. Can you solve this in an Azure function? If the answer is no, then you start to move backwards. Well, could I do this in an app service where I don't have to manage a cluster? If the answer is no, then it's like, well, maybe I'm okay with the Kubernetes service. I'm going to use like Azure Kubernetes service, and then so on and so forth. So try to optimize for productivity, make it so that you're managing less, that you're requiring your cloud vendor to do more. The other big point here, and I'll show you with the last demo, is that it's not an either or. We don't live in a world where you have to decide, I'm only doing serverless, or I'm only doing Kubernetes, or I'm only doing VMs. We really strive within Azure specifically to make sure that you have a rich spectrum and you can choose to run your applications or even pieces of your applications in the right environment that takes advantage of their strengths. Azure Functions' superpower is that it's event-driven and instantly scalable. If you have a workload that's like triggering on some type of event stream or queue, Azure Functions is a phenomenal strength for that. Kubernetes strength is that you have these rich microservice meshes that you can build together. If you want to build a rich, complicated microservice type framework, Kubernetes is fantastic at that. App services superpower is websites, web apps, web APIs, mobile backends. If you have something that's like my newsfeeder app, actually where I would probably host this thing, this RSS reader, would be in app services. So the final demo I want to show you now in the last 4 minutes, not thank you. Oh, I forgot a slide. There's more. This is the best part. I want to do one last demo where I'm actually going to pull this all together. So what I want to do, I mentioned we've got a little bit of a news theme here. So I want to show a different demo, but instead of doing an RSS news feed, I want to do a much more rapid news feed. So I actually want to be looking at tweets because Twitter is full of news all of the time. And specifically, I want to know what people are tweeting about the Avengers. Now, this is a spoiler-free demo. I'm not going to show any text here. But you will see a demo here in a second where I want to know every single person in the world who's tweeting about the Avengers. I want to know how many people are tweeting. I want to know where in the world they're tweeting from. And what's their sentiment? Are they excited about the Avengers or are they really sad? And I'm going to do that by actually combining containers, serverless, and Kubernetes into a single solution. So the first part here, this is my Azure function. This is going to be event triggered whenever a tweet gets sent. Now, behind the scenes, I'm leveraging Kafka and a Kafka stream to pull in that tweet data. But all I've had to write here in my function are these 29 lines of code that say, whenever somebody tweets about the Avengers, run it through some Python machine learning, figure out what the sentiment is, and then push it to Power BI. That's it, 29 lines of Python code, and I'm going to be scaling to all of the tweets about the Avengers. And there's a whole bunch. I did this last night at like 1 in the morning. There was a ton. Now, I want to run this, in this case, inside of Kubernetes, just to show that you can. And at Build, we announced a new project called Project Kata, which allows you to do event-driven scaling and Azure Functions, but run it in Kubernetes and have them scale the same way. So let's go ahead now and deploy this to Kubernetes quickly in the last minute or two that I've got. So I'm going to go ahead and apply this Azure function and deploy it to my Kubernetes cluster. Now, if I come back over here, I don't think I need this window anymore. If I come now here and I say get my deployments, here's what I want to point out. I have my function. It's deployed in Kubernetes. It's listening to events, but it's actually at 0 right now. It's not running at all, and that's because I haven't sent it any Twitter data yet. So just like Azure Functions in the cloud, when I use things like Kata, I can run Azure Functions in Kubernetes in the same way. And what I want to show you here is we'll say watch. Let's watch the pods in this case. So here's my newsfeeder app. You'll see that one there. And what I'm going to do in this next window is I'm going to now turn on the Twitter stream. And let's go ahead and say turn on all the Twitter stuff. And that's going to head here. You'll actually see a new pod that spins up called our Twitter to Kafka deployment. That's going to start pulling in Twitter data. And actually right away, you'll see that Twitter data is now coming in. So our first function spun up. My Azure function now running in Kubernetes just spun up. In fact, there's a lot of people tweeting about the Avengers, unsurprisingly. So now I have 4 functions that spun up. In fact, I imagine if I stay here for a few more seconds, you'll see 8, 16, and many more, because apparently Avengers is a really big deal. Now, if I come back over here to our dashboard, what we should see, the grand finale, there we go. So now this dashboard has lit up with real-time data. I can see anybody in the world right now who's tweeting about the Avengers. Anything above 0 means it's positive. So for the most part, all tweets are positive. We have some people in Kansas tweeting about the Avengers. We have some people in California. This map will refresh. I won't show the tweet text because I don't know if there's going to have spoilers. But here, using a combination of serverless functions, or at least the function programming model, Kubernetes, new technology like Kata, I actually can bring these worlds together. I can say, hey, I want the highly productive development experience of Azure Functions. But in this case, I want it to run in Kubernetes. Wow, there are a lot of people tweeting about the Avengers. I'm pretty sure Power BI is throttling me right now, which is why you're not seeing that get updated. But here you can see that I've spun up and I'm scaling like crazy here. And hopefully this dashboard will keep resetting. But I might have picked a bad time to tweet about the Avengers, but you saw that it works. That's great, okay? So you can mix and match, and I wanted to get that point across too. So hopefully this has been helpful, help you understand where each of these fit, how you can take advantage of them for their strengths, and within Azure, use a rich tool set to mix and match and use exactly the tech you want in the right spot. And this is now where I can close. So thank you all very much. I hope you enjoy the rest of your week. It's been great talking to you today.